There is a piece of paper somewhere in the archives of Soviet mathematics. On it is the proof that a problem declared impossible for 56 years, declared impossible by the greatest mathematician of the century, was solved in full by a 19-year-old student who did not know it was supposed to be impossible. The man who gave that student the problem was named Andrey Kolmogorov, and when I read what Kolmogorov had done, not just this, but everything, his whole life's work, I felt something I had almost never felt before. I could not explain it. We never met. We worked on opposite sides of an iron curtain that divided the world in two. I knew him only through his results, and those results told me something about the mind that had produced them that I did not know how to account for. My name is John von Neumann. I put quantum mechanics on a mathematical foundation. I built the architecture that every computer in the world still runs on. I helped design weapons that ended a war. By age 6, I could divide 8-digit numbers in my head. By age 18, I had published my first mathematical paper. People called me the most powerful mathematical mind of the 20th century. I did not correct them, but I could not explain Kolmogorov. And this is the story of why. Kolmogorov was born in 1903 in Tambov, Russia. His mother died giving birth to him. He never knew his father. He was raised by his aunt in a small village. She ran a school for village children, and she believed that the one thing that could not be taken from you was knowledge. Think about what that beginning means. No mother, no father. A village school. A Russia that was about to tear itself apart in revolution and civil war. His father died in the fighting before Kolmogorov was old enough to understand why. He arrived at Moscow State University as a teenager with almost nothing. And from the very beginning, he showed something no one around him could explain. As a young child, 5 or 6 years old, he noticed something that no one had shown him. If you add the first odd numbers together, you always get a perfect square. 1 plus 3 equals 4. 1 plus 3 plus 5 equals 9. He wrote it up himself. He published it in his aunt's school journal. He was listed as the editor of its mathematics section. He was not yet 7 years old. I want you to understand what that means. A child, alone, in a village, with no teacher who could match him, seeing structure in numbers that no one pointed out to him, not being taught it, seeing it, as if it were simply there, visible, and he was the only one in the room looking in the right direction. I grew up in a palace by comparison. My father was a wealthy banker. I had private tutors from the finest universities in Budapest. I had every advantage a mind could be given. Kolmogorov had a village and an aunt. And he found things I never found. And it only became stranger from there. At 19, he did something that stopped the mathematical world. He proved that something was possible that an entire generation of the finest minds in the world had believed was not. Not a guess, but a foundational conviction, something they had staked their understanding of how mathematics worked on. Kolmogorov, as an undergraduate who had been studying mathematics for barely 2 years, walked in and showed them they were wrong. The experts said there was no explanation for how a 19-year-old had seen what they had all missed. I was 18 years old when this happened. I was already being called a prodigy. I had already published my first mathematical paper. I thought I understood what exceptional looked like. I did not. I had seen prodigies before. I had been one. I knew what it looked like when a young mind moved faster than everyone around it. The quickness, the impatience, the ability to see 3 steps ahead while others were still reading the question. That was not what Kolmogorov did at 19. What he did was not faster. It was different in kind.
He had not simply outrun the experts. He had gone somewhere they had never been, somewhere they had not known existed. And he had come back with something in his hands that, by their own understanding, should not have been possible to carry. Kolmogorov went on to change mathematics in a way that almost no one in history has changed it. Not just one field, 5, 6, rebuilding each one from the foundations up, in the same lifetime, with the same mind. Mathematicians who knew him described the same experience again and again throughout their careers. A man who seemed to perceive mathematical structure the way most people perceive physical objects, not as something to be worked toward, as something already present, already visible, waiting to be pointed at. His students said his lectures were nearly impossible to follow, too fast, too dense, too full of ideas still forming in real time. But being in his presence meant being in the presence of a mind that was seeing things right in front of you, that no one else in the room could find. I worked with Einstein. I worked with Bohr. I worked with Fermi. I know what extraordinary looks like. Kolmogorov was different. I never stood in that room, but I read what came out of it. Paper after paper, field after field, decade after decade, and each time, the same feeling. Not admiration, something more unsettling than admiration. The feeling you get when you realize that the person on the other side of the page is not operating by the same rules you are, that they are not working harder or faster, that they are working in a different direction entirely, through a door you cannot find, and arriving somewhere you could not have reached, no matter how long you traveled. I have spent my life believing that all insight is, at bottom, computation. The mind moves through steps, even when it moves fast. I built computers because I believed that the right machine, moving fast enough, could replicate anything the human mind could do. I was writing a book about exactly this, the relationship between computers and the brain, when I died. My argument was simple. The brain processes information. Computers process information. The brain follows rules, chemical, electrical, mathematical. A machine that follows rules fast enough should be able to do anything the brain can do. I believe this completely. Kolmogorov made me doubt it, not because he was faster, because the steps were not visible, because the distance between what he knew and what he produced was shorter than it had any right to be. Because when those around him asked how he had arrived at a result, he would sometimes say simply, "I do not know how to explain it. I saw it." What does a machine do with that? What rule produces seeing? I did not know what to do with that. I still do not. In 1956, Kolmogorov turned his attention to a problem that had sat untouched for 56 years. Picture the greatest mathematician in the world, a man named David Hilbert, the man who had told an entire century which questions mattered, spending the final decades of his life obsessed with one problem he believed was simply impossible. He devoted more pages to it in his final published paper than to all 22 of his other great problems combined. He died certain it could not be solved. His funeral was attended by fewer than a dozen people. The Nazis had destroyed the mathematical world he had built. He never saw what happened next. For 56 years after Hilbert declared it impossible, mathematicians accepted it at a wall. And then Kolmogorov looked at it. He had been working on something else entirely, and somewhere in that work, he found a crack. A distinction that 56 years of the finest minds in the world had missed. He looked at the same words everyone had been reading since 1900, and organized them differently. He proved the first step himself. And then he did something I still cannot fully account for. He did not finish it. He walked into a room where a 19-year-old student was sitting. He put a piece of paper on the desk. He said, "Now finish it." Then he stepped back and waited. The student had no idea what was on that paper. No idea that the greatest mathematician of the century had spent 27 years on this. No idea that generations of brilliant men had tried and failed before he was born. No idea that Hilbert himself had called it impossible. He only knew what Kolmogorov had told him, that a first step had been made, that the rest was his.
He took the paper home that evening. He thought about it, and he solved it. The student's name was Vladimir Arnold. The paper was published in 1957. He was 19 years old. Arnold said later, "I did not know it was impossible, and so it was not." Think about what Kolmogorov did. He had been 19 himself when he first stunned the world. He knew, from the inside, what a mind looks like before it has learned its own limits. He looked at that young student and saw something that Arnold himself could not yet see. He handed him the wall and waited for him to walk through it. That is not the behavior of a great mathematician. That is something I do not have a name for. In his later years, Kolmogorov founded a school for gifted young students at Moscow State University. He taught there himself mathematics, but also literature, music, and physical fitness. He believed the mind that sees everything must also live fully. He died in Moscow in 1987. He was 84 years old. His students visited him in his final years when he could no longer work the way he once had. They said he still asked questions, still wanted to know what they were working on, still believed the most important thing was to show someone younger a problem, and then step back. He is buried in Moscow. Most people outside of mathematics have never heard his name. I find that remarkable. Not sad. Remarkable. The man rebuilt how we understand chance, disorder, and complexity. The machine you carry in your pocket runs on mathematics that would not exist without him. And yet you have almost certainly never heard his name before today. Perhaps that is the final thing that separates him from the rest of us. We wanted to be known. We gave lectures, wrote books, moved between the powerful and the famous. I attended parties at the White House. I advised presidents. Kolmogorov taught literature to teenagers in a boarding school outside Moscow and asked his dying students what they were working on. I think about that often. The world is full of geniuses. I have met many of them. I may have been one of them, but every few centuries, something else appears. A child in a village school who sees structure in numbers that no one showed him. A teenager who proves something impossible that a generation of experts accepted as a wall. A man who finds a crack in a 56-year certainty and hands the rest to a 19-year-old because he alone could already see the 19-year-old finishing it. I built computers because I believed a fast enough machine could do what the human mind does. I still believe that. For almost every mind I have ever encountered, I believe it completely. But when I think about Kolmogorov, I am not sure the machine I imagined would have been enough. I do not have a scientific explanation for that. What I know is what I saw when I looked at that man's work across an iron curtain, across an ocean, from the other side of a world that kept us apart our entire lives. I saw something that had no right to be human, and yet it was.